Number 2, we're given that triangle PQR is congruent to triangle STU. We could draw these two triangles. However, we know that order matters in congruent statements. Thus, angle P is congruent to angle S, angle Q is congruent to angle T, angle R is congruent to angle U. Likewise, we know that PQ is congruent to ST, QR is congruent to TU, and RP is congruent to US. So on A, when it says circle the pairs of lengths that must be the same, PQ should be congruent to ST. However, those aren't one of our options. So we move to the next pair. QR is congruent to TU. That is listed, so we will circle QR and TU. Now, if these two are congruent, we know that the sides are also going to be congruent. So if they give us that QR is equal to 8x minus 4 and TU is equal to 7x plus 1, all we have to do is set up our equation where 8x minus 4 is equal to 7x plus 1 since they are congruent sides. So write that down. 8x minus 4 is equal to 7x plus 1. Next, I want to get all of my constants on one side and all of my x terms on the other side. I have a minus 4, so I'm going to undo this minus 4 by adding 4 to each side, moving it to the other side. These will cancel, and I'm left with 8x is equal to 7x, and then I have this 1 plus 4, which is 5, so plus 5. Next, I'm going to move my 7x to the other side by undoing it with the opposite sign. So I'm going to subtract 7x from each side. I get that these cancel, and I'm left with 8x minus 7x, that's just 1x, is equal to what's left over on the right side, 5. So x is equal to 5. Now, in order to find all of these lengths, I just plug in x for 5. I know that PQ was congruent to ST, so these two sides should be the same. When I plug in when I plug in x equals 5 for PQ, it's going to be 5 times x, so 5, plus 7. So 5 times 5 plus 7. 5 times 5 is 25. If we add 7, we're going to get 32. So PQ is equal to 32. And since PQ is congruent to ST, we can put that ST is also equal to 32. Next, for QR, when I plug in my x of 5 for QR, I should get the same answer for TU since these were congruent, and I set up my equations stating that they were equal. So QR is equal to 8x, where x is equal to 5, minus 4. So we get 8 times 5 is 40, minus 4 equals 36. So QR is 36. Next, for TU, we could say it's just 36 due to the fact that these are congruent, but why not plug it back in as well? So TU was equal to 7 times x, so in this case 7 times 5, plus 1. 7 times 5 is 35, plus 1, we get 36, which is the same as QR. Next, for US, we saw that it was equal to 6x, so we just plug in 5, so 6 times 5 is equal to 30. US is congruent to PR, so we know that that will be 30 as well. And now we're done. Number 3, here's our first congruence proof. We always start with the first statement, and we have to provide a reason. They say that B is the midpoint of AD. So if B is the midpoint of AD, why is that? Our reason is that it was given to us. It's in that provided information. So we write given. Now, because of the fact that B is the midpoint of AD, we know that AB is congruent to DB. And the reason is definition of a midpoint. Next, AD is perpendicular to BC. How do we know that? That was given to us. So once again, we write given. Now on the next blank, it has that the reason is definition of perpendicular. What do I know when I have a line that's perpendicular to another line? They form right angles. So if AD is perpendicular to BC, we have a right angle here and a right angle here. So we can say that angle DBC and angle ABC, that we can say they are right angles. Next, on my next line, it's written that angle DBC is congruent to angle ABC. On the previous line, when I state that they're right angles, I haven't stated that they're congruent yet. So I have to go and say that in the next statement, which is written here. And the reason for that, all right angles are congruent. Now, we have one more set of blanks before our final congruence proof theorem. So, we look to see if there's anything else that we can identify in our triangles. We have the reflexive property. We see that CB is congruent to itself, CB, due to the reflexive property. So now we have enough information to prove congruent triangles. The reason for that, DBC, triangle DBC is congruent to triangle ABC, is because of side, angle, side. The angle is held between the two sides. And now we've proved congruent triangles. B, our next congruence proof. We have that BD and AE bisect each other, which was given. Whenever a side is bisecting another side, we know that we are going to get two congruent sides. So if they're bisecting each other, we're going to get two pairs of two congruent sides. So if BD is bisecting AE and vice versa, our first statement below that is BC is congruent to. We know that BC is going to be congruent to CD. The reason for that, definition of a segment bisector. Next, AC is congruent to. We know that AC is congruent to CE, just like before, because of definition of an angle, or I'm sorry, a segment bisector. Next, we have a blank. That means that there's something here that has not been proven congruent, but it's always congruent. In this case, we have this bow tie shape, so we know we have vertical angles. So we have got a vertical angle here with BCA and a vertical angle here with DCE. So we can say that angle BCA is congruent to angle DCE. Reason for that, vertical angles are congruent. Now we have enough information to prove two congruent triangles. Like before, the angle is included between the two sides, so this is side, angle, side. Triangle ABC is congruent to triangle EDC by side, angle, side. Next, C, our last proof. We're given that angle B is congruent to angle E, so we can mark that. Angle B is congruent to angle E. They also give us that BC is congruent to EA. BC is congruent to EA. Next, angle C and angle DAE are right angles. Angle C and angle DAE are right angles. All of these are given to us. We also know something else. We know, because of the fact that those are right angles, that they are congruent. We haven't stated they're congruent yet, so we have to do that. We've only stated that they're right angles. So we're going to say that angle C is congruent to angle DAE. And the reason for that, all right angles are congruent. Now we have enough information to prove two congruent triangles. Angle, side, angle. The side is included between the two angles. So we can say triangle ABC is congruent to triangle DEA. And the reason for that is angle, side, angle. Now, we want to prove, our end goal here is to prove that A is the midpoint of CD. So if A is the midpoint of CD, we should know that CA is congruent to DA due to that definition of a midpoint. However, we're working backwards. So instead what we do is we prove AC is congruent to AD, and we know that because of CPC-TC, which is corresponding parts of congruent triangles are congruent. So we have enough information now to say that A is the midpoint of CD due to definition of a midpoint. And now we're done.